Hello everyone, welcome to my channel C.S.E-Pathshala. We are studying about machine learning using Python 3 and our topic for this tutorial is NumPy array indexing. So if we talk about NumPy array indexing, it is same as accessing array elements, and we can access array elements by referring to its index numbers. Okay, we have already seen that array indexing starts from 0. Okay, and that means it represents the first element, and then the index 1 represents the second element. So usual notation of an array, we consider the same as here for accessing elements, what we do in reference to the array indexing. So let's consider a code here. Let's copy it, and I am having Jupyter notebook here. I pasted the code and we tried to implement array indexing. So in this we have written import NumPy as np, and we are declaring a variable arr that is equal to np.array, and we are giving a list as an argument here. We have seen this notation in the previous tutorials also, and in the statement 3 and 4 we are trying to access elements which are present at arr 0 and arr 1. Okay, so let's save this thing, run this thing. So here we have got both the elements. Okay, now we can also access elements and add them. So let's consider one more code. So here it is. Again, import NumPy as np, arr equal to np dot array 1 2 3 4. That means we are taking list as an argument, and it's a one-dimensional array which we are talking about. And in the statement number 3, what we are doing is we are adding the elements which are present at index 2 and index 3. So as we know that the indexing starts from the 0, so the element which is present at arr 2 index shall be 3, and at arr 3 index will be 4. Okay, so let's save this code, run this code. So here is the output. That means 3 plus 4 is 7. Okay, we can also access 2D array elements, and in order to access 2D array elements we can use comma separated integers representing the dimension and index of the element. Okay, so here we are having an argument in the form of integers, where the first argument represents the dimension and the second represents the index of the element. So let's consider a code here and implement it on Jupyter notebook. Okay, so again import NumPy as np, arr equal to np dot array. We have given here a list as an argument, but it is clear that we are using 2 square brackets. Okay, if it has been 1 square bracket here, that means it's a 1D array, but if we are using 2 square brackets, that means it is a 2D array. Okay, now we are printing this array. Okay, in the statement number 3. In the statement number 4, we are printing its dimension. This we have seen in the previous tutorials also. In the statement number 5, we are printing its shape. This also we have seen in the previous tutorial. At statement number 6 and 7, we are printing the elements which are present at index 0 and 3 with respect to the dimension. Here it is 0 and here it is also 0. Okay, so I just want to make one thing clear. Let's first run this code, okay, and get the output. See, the output is, for the first one, this is an array. It's a 2D array. Second, it's a dimension, so it's 2. Third, if you're talking about the shape, that means it's of 1, 4. That means it's having 1 row and 4 columns. Okay, and the elements which are present at 0, 0 arr, that is 1, and the element which is present at 0, 3 arr, that is 4. Now how we are getting these elements? See, it's quite clear that we are having a single list here, and we are talking about a 2D array. Okay, so here we are having 2 dimensions. That means one is 0 axis and one is 1 axis. Okay, if you're talking about two dimensional array. Okay, since we are having only one list elements here, so these elements are present at 0 axis. Okay, and there is no element present on 1 axis. Alright, so this 0 represents the 0 axis and 0 stands for the index, and 0 is the first index of this list. That's why if we are accessing 0, 0, it's printing 1. Now, if you proceed further, this is the 1th index, this is 2th index, and this is the 3rd index. So if you're talking about 3rd index, it's printing 4. Now, as I've already told that there is no element present at 1 axis. So if we try to access an element like this, 1, 0, so definitely it will give an error. Okay, so save this thing, run this thing. Okay, so here it is. It's an error on this line because index 1 is out of bounds for the axis 0 with size 1. Okay, since there are no elements which are present at the axis 1, so we are getting it out of bounds. Okay, so it's an error here. Alright, so let's change it again. Now save and run this thing. We are getting the same output. Alright, now let's take one more example. Here we are taking two lists as an argument, and now we are also giving elements at the axis 1. So let's consider this code. Import NumPy as NP. List 1 we are having elements 1, 2, 3, 4, 5. List 2 we are having elements 6, 7, 8, 9, 10, and we are giving both lists as an input separated by comma. Okay, and it is also a 2D array. So definitely the elements of list 1 are present at 0th axis and the elements of list 2 are present at 1 axis. Okay, so let's first save and run this code, get the output, then we will understand. So here it is. Here's the matrix. So if we talk about the dimension, it is 2D matrix. Obviously, if you talk about the shape, then it comprises of 2 rows and the 5 columns. It's already visible, 2 rows and the 5 columns. Okay, now if we try to access the elements which are present at 0, 0, that means at 0th, this is the 0th thing. Okay, this is the 0th axis. So 0, 0, that means 0 is the first index number, that is 1. So at the 0th axis, we are talking about 0 index number, that is 1. Now 0, 1, that means this is again 0th axis and we are talking about 1 index number, that is 2. Now next we are printing 1, 0, that means this axis, and 0 is the first index element, so it is 6 here. So here are the outputs of this code. Okay, now let's consider one more code. Okay, so here it is. We can also access values present at index values 2 and 4, that is 3 and 5. That means what we are doing here is, besides using an index to access elements in an array, we can also use list as the index. Okay, so let's consider this code and implement it here. So again, import NumPy as NP, list 1, that means we declared a list here with elements 1, 2, 3, 4 and 5. We are given it as an input to np.arr array, and we are accessing the values of arr 2, 4. Okay, so as I have told here that besides using index to access elements, that means apart from giving an index, we can also use list as an index. So we are using 2, 4, this list as an index here. Okay, so what will it gonna print? Let's save this thing, run this thing. So its output is 3, 5. So what this output represents? Okay, let's check. We have given list as an index here. Okay, so 2, this position 2. That means if we talk about the index of this list, 0th position we are having element 1, 1th position we are having element 2, second position we are having element 3. Okay, so here we are talking about second index value. So second index value is 3. The third index value is 4 and the fourth index value is 5. So here it is 4. So we are talking about the element 5 here. Okay, now if we change the index values here, for example, let's make it as 1 and make it as 3. So the output will be 2, okay, because its index value is 2 for 1 and 4 for the index value 3. Okay, so let's again save this thing, run this thing. So here it is, we are getting 2, 4. Alright. So now if we access 3D array elements, to access 3D elements, we can use comma separated integers representing dimensions and the index of the elements as we did in 2D arrays also. Okay, so let's just implement a code. So here it is, import NumPy as np, arr equal to np dot array. We are using a list here, okay, and there are 3 square brackets, okay, for these elements. So it means that we are having an 3-dimensional array. Apart from this, we can also declare a list, and we can take list here as an argument with 2 square brackets, but we are not taking something like that. So here the elements are present, so there are 3 square brackets here. Okay, now if we try to access an element 0, 0, 2, okay, one more thing which we need to see here is, it's a 3D array, 0 axis, 1 axis and 2 axis, that means 3 axes are present. Since it's a single list here, so all the elements are present at 0 axis only. There is no element present at axis 1 and axis 2. Okay, so if we talk about 0, 0, 2, it represents 0 stands for the outer axis, that is axis 2. 1 stands for 0 stands for again here this is 1 axis and this is the inner axis or the 0 axis. Okay, so if we talk about, let's save this code first and run this code. So we are getting output as 3. How we are getting output as 3? Okay, there are no element present at second axis, there are no element present at 1 axis. Now if we talk about 2, this is the inner axis and its index values will be 0, 1 and 2. So 2, its element is 3, okay, so it has been printing 3. Alright, now if we just change its values, for example, if I do 1 here and there are no elements present in the 1 axis, we already told, so definitely it will print an error. Save this thing, run this thing, obviously. Index 1 is out of bounds for the axis 1 with the size 1. Okay, so since we are taking a single list only, so axis 1 and axis 2 are not having any elements. So whatever the indexing we need to do here, that will be regards to the 0th axis. That means this is 0th index, 1 element, 1 index, 2 and second index, that is element 3. Okay, so save this thing, run this thing, we are getting the same output again. Alright, consider one more code. So here we are using 2 list as an arguments here to the array. Okay, now we are trying to access ARR 0, 1, 0. Okay, so it's better first we print this array. Okay, so let's print this array first. We can see how it's getting printed, what's the shape of 3D array here. So let's save this thing, run this thing. Okay, here is the shape. Okay, now we are seeing 3 opening and the closing square brackets. So it's quite clear that it's a 3D array. Okay, now inner square brackets represents the 0th index, outer square brackets represent the 1th axis, and the outer square brackets represents the second axis. Okay, since we are not having any elements on the outer axis, okay, so its value is being 0. Now if we talk about the inner axis or one axis, we are having see, this square bracket is one axis, so it is having again two components, that means 0 and 1. So this is two rows, this is the 0th thing and this is the 1th thing. Okay, so axis 1 is having 0th row and the 1th row. Okay, in corresponding to that, again इसके अंदर क्या है, 0th axis है, so 0th axis is also having 0th row and the 1th row. Okay, so if we talk about 0, 1, 0, that means it's representing 0s, this is the outer axis, we are not having anything here. 1, this represents this row, okay, and 0, this is the index value of your inner axis. Okay, so the output is 4. If we have taken 1 and we have taken it 2, so it will print 6. Why? Because 1 is this row only and 2 is the index of, this is 0th index, this is the 1 index and this is the 2nd index. So it shall be printing 6. So let's save this thing, run this thing, so output is 6. Now if we just change this thing, we just make it as 0. Okay, so it shall be printing 3. Why it shall be printing? Because we are talking about this row. Okay, 0, we are talking about this row, and it will be printing 0, 1 and 2, this index value, that is 3. So let's save this thing, run this thing, so it's 3. Okay, let's consider another code. So here it is, let's copy this thing. Okay, and okay, again here what we are doing is we are taking 2D 2D arrays as an argument here, separated by comma. That means this is a 2D array, this is a 2D array, okay, and we are going to make it as a 3D array. Okay, so let's save this code and run this code, and please check how it looks. So it looks like this. Now what's happening here is, again, this is the outer square bracket and this is the closing of outer square bracket. It shows that this complete represents 0th and this complete represent 1 row of the outer axis, that means axis 2. Okay, so axis 1 is representing here that it's 0 row and 1 row for inner axis 1. In regards, and this is also 0th row and 1th row, okay, for the inner axis 1. And with respect to this 1th axis, we are taking the last axis, that is 0 axis. Its value index is having, this is the 0th index, 1th index and 2nd index. This is again 0th index, 1th index and the 2nd index. Similarly, 0th index, 1st index, 2nd index, and again 0th index, 1st index and the 2nd index with respect to the outer 1th axis. Okay, and again in regards to the outer 2nd axis. Okay, so now if you are trying to print a value ARR 1, 1, 2, it represents 1, that is the outer axis 1. So I have already told that this represents 0 and here this represents 1 for the outer axis. So this is the outer axis, so 1 means we need to look here. Now again here it is 1, so it represents the 0 and it represents the 1 for the inner axis. So 1 we have to look for here, and 2, it represents 0, 1 and 2. So the output will be how much? The output will be 12. So save this thing, run this thing, so output is 12. Okay. Now We can also perform negative indexing, and negative indexing means to access an array element from the end. So let's consider this code here and implement it here. So again, we are taking ARR equal to np.array. We are taking a single list, 1D array, and we are trying to access an element which is present at ARR -1. Okay, so that shall be the last element of this array. So save this thing, run this thing. So output is 5. That is the last element. Okay, let's take one more code and take it as a 2D array. Okay, so just save this thing. Okay, so here is the code. We are taking ARR equal to np.array. It's a 2D list because we have mentioned 2 square brackets here. Okay, again, since we are having a single list, but here it is representing a 2D array, so all the elements are present at 0 axis and none of the elements are present at 1th axis. And if we are accessing an element here, that is ARR 0, -1, 0 means this array. Okay, -1 means the last element of this array, so it is 5. So let's save this thing, run this thing. So here it is. If you just write like -2, so it will print 4. Okay, and if we just try to access the elements at 1 axis, obviously it will give an error. So save this thing, run this thing, it will an error because index 1 is out of bounds for the axis 0 with size 1. Okay, so let's recorrect it and save and run it. So here is the output. Alright, let's take 2 list as an argument. Okay, so here we are taking 2 list as an argument, and again it's a 2D array. Why it's a 2D array? Because we are using 2 square brackets here, and we are trying to access an element which is present at 1, -1. So again, let's first print this array, so it will be very much easier to understand what's the shape of it. Okay, so let's save this code, run this code. So here it is. Now, it's quite visible that it's a 2D array, so all these elements represent 0 axis and all these elements present 1 axis. Okay, and if we talk about ARR 1, -1, so we have to look for 1 axis, and -1 is the last element of it, that is the 10. So here we are getting the output as 10. Now if we just do like this, 0, -1, so it will print the value 5 because at the 0th axis the last element is 5. So let's save this thing, run this thing. So here is the output 5. Okay. Now we can also perform Boolean indexing. So what do we mean by Boolean indexing? In addition to using indexing to access elements in an array, there is another way to access the elements in a NumPy array that is called as a Boolean indexing. And what does Boolean indexing do? Let's consider a code here. Alright, so here import NumPy as NP. We are declaring a list, that means it consists of elements 6, 7, 8, 9 and 10. We are giving list as an argument to np.array. Okay, and we are printing array here, that is obviously a 1D array. And what we are doing next here is we are printing ARR greater than 7. So what does it mean? It means that in an array, if an element is greater than 7, then it will print true, else it will print the false values. Okay, so let's save this code, run this code. So here it is. So here is the 1D array of the list, and here are the values: false, false. Obviously, first value is 6, so it's not greater than 7, false. 7 is not greater than 7, it's false. So 8, 9 and 10 are greater than 7, so its values are true. Okay. Now next, let's consider one more code. Okay, so here it is. Okay, and what we are doing here is, see, what we can do here is we can feed the list results back into the array as the index. Okay, so let's consider this code. Here what we are doing is we are again feeding back the list results into the array as an index. Okay, so let's check this code first. Again, import NumPy as NP list. We have declared here, we are giving it as an argument. Okay, so just make it as list. Okay, and here we are printing this array. We are printing the Boolean values here, and we are giving this as an argument again to the array. Okay, so let's save this thing, run this thing. So here it is. Now what happened is, whoever the values are true here, that will be printed. That means 8, 9, 10, they are greater than 7. So we have given this again as an index to the array. So it has printed 8, 9, 10, these values, and the first two values 6 and 7, since they are false, they are not satisfying the condition, so they are not printed. Okay, again we can also retrieve all the odd numbers from the list, and with the help of this Boolean index in a very simple manner. So let's consider this code again. Alright, so import NumPy as NP, nums, that is again a variable. Here we are using a function arrange that will take, here we are given an argument as 20, so it will take values from 0 to 19 in a form of a 1D array, and we are printing this thing. We are again taking a variable that is odd underscore num, that is equal to num, nums n%2 is equal to 1. Okay, so what we are doing here is, if numbers which we are taking here, there is modulus done with respect to 2, as we know that how to check whether a number is even or odd, and if we are getting a reminder as 1, so obviously it's a odd number. Okay, so here's the concept which we have used above program. Similar we are using here. Okay, so let's save this code, run this code. Okay, so here it is. So this is the complete list which we have used here. That means arrange 20 1D array from 0 to 19 numbers. And here what we did, we used a condition that if a number is giving a reminder that is equal to 1, we are printing it as an odd number. So whoever elements are satisfying this condition, we have printed all these. Okay, so this is how you can use Boolean indexing. So that's all for this tutorial. Thanks for watching. Kindly subscribe to my channel.